Okay, so you can get your sig figs two ways. Either you make a measurement and your sig figs come from the instrument that you were using, or you can get handed a set of numbers and you have no idea who made the measurement, but you have to trust their sig figs. When you are doing operations in chemistry, very often you get handed a set of numbers. You have a problem in the book, you have a problem on a test, you don't know who made the measurements, but you have to go with their sig figs. Still the 21st. So there are two sets of rules for doing operations with sig figs. I will say that we most often end up using the rules for multiplication and division, but you should be aware of both sets of rules. When you are adding and subtracting, the answer has to have the same number of digits right of the decimal behind the decimal. Okay, so what that means in practical terms is that when I add 1.2 and 1.2000, my sig figged answer, might have a whole bunch of zeros. My sig figged answer will not have a whole bunch of zeros, sorry. That's my raw answer, but how many numbers behind the decimal point can I have? The same one, the same as the fewest in anything that went into that calculation. So my final answer is going to be 1.2. I have to have the same number as the number that went into my calculations that has the fewest. The only things that affect your sig figs and your final answer are numbers that went into your calculation. If you didn't use them, you don't have to think about them. Okay, if I take 4.75 minus 1.5. Okay, my raw answer is 3.25. What's my sig figged answer? Okay, we're about to talk about rounding. That was a perfect lead-in. Yes. Okay.
Why is the addition is 1.2 plus 1.3?
Because I screwed up. That was a fantastic question. I'm glad we're still recording. Why is 1.2 plus 1.2 1.2? Because apparently 2.5 cups of very strong coffee is not enough. Let's revisit that, shall we? Okay, is that better? Oh, good God. Do I have to up my dose again? Okay, thank you. You know the saddest and most ironic part of the whole thing? I thought, well, let's keep the math easy for you, Moser, so that you can do these quickly off the top of your head. See how well that worked out. Okay, is that better? Okay, so just keep checking my math, please. So 4.75 minus 1.5. Raw answer is 3.25, isn't it? What's my final sig figged answer? We can only have one behind the decimal, so you're right. But we have to think about rounding. It's going to be 3.3. There are more and less complicated rules for rounding. I choose to use the less complicated rules for rounding. If it's 5 and up, it rounds up. And we're going to talk about rounding in a second. So the sig figged answer for that would be 3.3. Okay, adding and subtracting, the rules are pretty easy. For multiplication and division, it's not that they're any harder, it's just that they're different. What they have in common is that in both cases we're looking at the lowest number of something in what went into our calculations. The lowest number of digits behind the decimal or the lowest number of sig figs overall. So in multiplication and division, the answer can't have any more sig figs than there are in the measurement with the fewest sig figs. So if I take, let's see if I can actually do this, 2.50 times 2, 5.00. That's my raw answer. What's my actual sig figged answer? 5, just 5. I can only have one sig fig, and that's dictated by the lowest number of significant figures in anything that went into my calculation. Just because I'm going to grab my calculator. All right, what if I have 7.25 times 4.29. Okay, there's my raw answer. What's my sig fig answer? Talk about it amongst yourselves. Do you agree with everybody at your table? Is that my sig fig answer? Yes. I can have 2 sig figs. What's governing that? This. That has 2 sig figs in it, so my answer can only have 2 sig figs in it. My answer is limited by the number of sig figs that went into the operation. So what do you have to be able to do here? You have to be able to determine how many sig figs are in the numbers that went into your calculation, and then you have to be able to round your answer appropriately. So the skill that you just used and practiced in part 1, you're now going to use in part 2. A word about scientific notation. In scientific notation, every number that we show in scientific notation is significant. If you say 4.000 times 10 to the 23rd, that has 4 sig figs. All those zeros are significant. If we say 4.0207000 times 10 to the 23rd, all those numbers are significant. And it makes it didn't connect for me until, like, I don't know, a couple years ago. Well, of course, because based on the rules for zeros around decimals, any zero behind the decimal is significant. Zeros at the end of the number behind a decimal are significant. So if you have a number like this, 30200, and you want to put that into scientific notation, and you want to correctly show the number of significant figures that were in that original number, go ahead and do it. Put it into scientific notation and correctly show how many sig figs are in that original number. Whoops, okay. Okay, so now I want you to try the calculations on the practice sheet. There are 2 sections of them. Don't try the rounding yet because we're going to talk about the rounding. I didn't used to have a slide for this. As I said, I didn't used to have this slide, and I didn't used to have this slide because I said, okay, this is easy. 0 to 4, you round down. 5 and above, you round up. What's so hard about that? They get it. You know how to round. And what I didn't realize until I had taught chemistry for a few years is that there is a trick, there's a pit into which students will fall when rounding large numbers and very tiny numbers in and talking about sig figs. So I put this in here, and we'll kind of practice it together. Everybody has an easy time when they're rounding back here, behind the decimal. That's easy, because you just keep dropping numbers off. Now, you know, to give you the general statement about rounding, when you are rounding a number, let me erase my little scribbles here. If I am rounding to 10 sig figs, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the last number I'm keeping, and I'm going to round it based on the number that comes after it. And I sometimes, to this day, will draw a little line under the last number I'm going to keep, and then I look at the number after it, and that's how I'm basing my rounding. So 0 has a 9 after it to 10 sig figs. I'm going to round that up. It becomes 607,516.0611. Easy. To 9 sig figs, well, I'm going to do the same thing, essentially. I'm going to count. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm keeping this, and I'm rounding it based on that. So, you know, there we go. It's really easy as long as you're rounding behind the decimal. Here's where it gets hard. Right here and beyond. So when I'm rounding this number to 6 sig figs, this one isn't hard. 1, 2, 3, 4, 5, 6. Okay, it's the last digit before the decimal. I'm rounding it based on what comes after it. So that's just going to stay the same because it's below 5. Okay, well, what happens when I go down 1? I'm going to take this to 5 sig figs. So 1, 2, 3, 4, 5. That's the last number I'm keeping, and I'm going to round it based on this. 6075. And I'm rounding this based on what comes after it. So it's going to be a 2, but I have to do something. I have to add a placeholder 0 here. I can't just drop numbers off the end of a number and expect that it has the same value. So if I owe you $720 and I say, well, here's $72, is that good? Is that the same amount of money? No, because you drop those placeholder zeros. You know, there's a difference between, hey, I owe you $5,000 and, well, I'm going to give you $5. We cool? No, we're really not. So you have, when you're rounding in front of the decimal, you have to make sure that you're maintaining those place values. So you always have to, if you are dropping numbers off as non-significant that are in front of the decimal, you have to keep their place values by inserting zeros. Okay. Now what if we have a number like this, 001347, and I need to round it to 2 sig figs. I want to take this to 2 sig figs. I can show you the most common mistake that people make, and some people made it on an answer in the other part. They go 0.13. That's one of the most common mistakes. The other most common mistake is to go, well, 0.00. Neither of those is right. When you're rounding a number that is a decimal number less than 1, and you're going to be taking it down to some smaller number of places, and it's got lead zeros, it's got those placeholder zeros behind the decimal, you don't start counting your sig figs until you hit your first sig fig. So I want to take this to 2 sig figs. I'm not going to start counting here and here because those aren't significant. I'm going to start counting here. 1, 2. This is the last digit I'm keeping. I'm rounding it based on this. You have to maintain your placeholders. So the answer for this is 0.0013. Okay. So now I'm going to have you do the rounding practice. I'm going to float around. When you come in tomorrow, we'll look over the rounding practice. We'll probably do some problems together, and then we'll see where everybody's at, and we'll see if you're ready to take a FIP quiz. Okay? That's it.